Hello, I have a video here that's going to help us calculate angles of elevation and angle depression, or use one of those angles to help us find something else. Before we actually get to using them or calculating them, we need to figure out what are they. So my first one says it's the angle formed by a horizontal line of sight and a line of sight below it. That is going to be referred to as the angle of depression. And I look at this and there's a couple of very important pieces of this. This angle is created by a horizontal line and a line of sight below it. So I look at my picture down here and I can see my angle of depression. Notice, like I said, there's the horizontal part and then there's the part that goes down. So I think of an angle of depression as one of the sides goes down. That's going to be very helpful when remembering which one's which. Now my next one, angle formed by a horizontal line of sight and a line of sight above it. That is our angle of elevation. And again, two important pieces, horizontal line and a line above it. So in my picture, we have the blue, the angle of elevation, and again, horizontal line and a line above it. So we can see that one of the sides of the angle of elevation is going up. The big piece to remember is one side of an angle of depression or an angle of elevation has to be horizontal. And if we think of it that way, then the other side is what's going to make it a little bit easier to figure out which is which. If the one side's going down, angle of depression. If the one side's going up, angle of elevation. But remember, one side has to be horizontal. Now I have a couple examples on how we're going to use those to solve some problems. So in this one, this one's kind of nice because it gives us the picture, but the problem tells us that we have a salvage ship uses sonar to determine that the angle of depression to the wreck on the ocean floor is 13.25 degrees. It says the depth chart shows that the ocean floor is 40 meters below the surface. How far must the diver lowered from the salvage ship walk along the ocean floor to reach the wreck? So we have our little diver down here. He needs to now walk from his ship all the way to this wreck to recover it. And we need to know how far does he have to walk. Well, this picture has everything drawn in it for us. So we have the angle of depression. Notice it drew it in there. One side was horizontal, that's this side, and one side goes down. So we get our angle of depression in there. Now the other piece that it told us is the depth chart at this spot tells us that our wreck is 40 meters below the surface. And we need to figure out how far he's going to walk. Well, when I look at this, how far he walks would be the same as how far he could have swam to get there. So I look at this and go, this is a right triangle. How am I going to find that side of my right triangle? I'm just going to call that x. So we just need to set this up. So right now, I look at it and I throw away all the words, I throw away the picture other than the triangle part, and I just look at how are we going to use trigonometry to help us calculate the length of that missing side. So I look at this and I go to the angle that I know, and now I ask myself, which side am I looking for from that angle? Well, the side that I'm looking for is the adjacent. Which side do I know? I know the opposite, so I have adjacent, I have opposite, and I ask myself, which trig function worked with adjacent and opposite? Well, that was tangent. So I'm going to have to set up a tangent equation. So I'm going to have the tangent of my angle that I work from, 13.25. And the tangent is going to equal the opposite side, which is 40, over the adjacent side, which is x. And now we just go through and we solve this proportion. So the first thing I like to do in my proportions, or my equation in these types, I like to make the proportion, and now I can cross multiply. So I'm going to cross multiply this way, and we're going to end up with a tangent of 13.25x equal to, well, when we cross multiply this way, we just get 40. And then we go through and to get that x all by itself, we're going to divide both sides by the tangent of 13.25. Because remember, there's multiplication right there, which means we got to divide this side by the tangent of 13.25. Well, left side now is just x. Right side, I'm going to come to my calculator. I'm just going to type it on my calculator. The 40 divided by tangent of 13.25. Tangent 13.25. Push enter. And we just figured out that the distance that diver is going to have to walk is about 169.87. And then we'll get our label on that. 169.87, and then we come up here and we look at what were the labels in our problem. Well, we were talking meters for the depth of the water, therefore this has to be meters on our distance he or she has to walk. All right, I have one more example. This one we want to calculate the angle of elevation of the sun where a 7.6 meter flagpole casts a 18.2 meter shadow. I'm a person who loves pictures, so I'm going to try to draw this picture. So we have this sun up here in the sky shining down on a flagpole. So here's my flagpole, and we know that flagpole is what? 7.6 meters. Now it makes a shadow. There's my shadow. Very artistic, I know. And our shadow, it tells us in the problem, is 18.2 meters. So I look at this, and our sun is making that. So the sun has this angle coming down in here, right here. Flagpoles, built right, are perpendicular to the ground. Now I have this right triangle, and it wants us to calculate the angle of elevation. Right here, angle of elevation. Well, remember, angle of elevation, one side has to be horizontal, and the other side then has to be going up. So look at my right triangle, and I go, oh, angle of elevation, I have my horizontal side. That would be the bottom of my triangle. I have a side going up here. I just found my angle of elevation. Let me get rid of that stuff. So I'm going to call this x. That's the angle that we're looking for. So now it's just a matter of setting up our trig equation, and we'll have it. So I look at this and go, from my x, I know the opposite side, and I know the adjacent side. Which trig function do I use? Well, I'm going to use tangent. Now, don't think we always use tangent just because I use tangent on these two examples, but for these two, tangent is going to work. So tangent, now remember, tangent is the opposite side, which was 7.6, over the adjacent side, which is 18.2. So now, we have to get the XL by itself. So we have to get rid of the tangent. Now remember, this is where we're going to use the inverse of tangent. So we'll take the inverse of tangent of the left side. We're going to take the inverse tangent of the right side, and we will now have the measure of x in degrees. But this is where our calculator is going to come in handy. So on this one, remember, to get the inverse, we push second and then tangent. And then I type in 7.6 divided by 18.2. I push enter, and I find out that the measure of my angle of elevation is 22.66 degrees. So the angle that the sun is at that point in time during the day is 22.66 degrees. And that's going to conclude my video lesson on angles of elevation and angles of depression.